Beneath the shadows of Geneva, far below the world's surface, lies a stunning achievement of human innovation and an inevitable harbinger of devastation. The Large Hadron Collider, LHC. It stands as a marvel of intelligent analysis, allowing scientists to probe the subatomic realm and triggering the discovery of the elusive Higgs boson, often dubbed the God particle. This breakthrough has captivated the scientific world. Yet, as renowned physicist Brian Cox once ominously declared, a hidden potential has been uncovered at CERN, sparking a wave of curiosity and concern. Could our pursuit of knowledge have led us down a dangerous path? Have we set our course for an uncertain future, possibly one that defies our understanding? Before delving deeper into the startling statement, it's essential to first examine the colossal machine that is the Large Hadron Collider. Operated by CERN, the LHC is an imposing 17-mile ring of superconducting magnets, and it is by far the largest and most powerful particle accelerator ever built. It stands as the pinnacle of scientific accomplishment, capable of recreating conditions that rival the birth of the universe itself. This incredible apparatus allows scientists to explore the fundamental components of the cosmos, but with such immense power, could it lead us to unforeseen consequences, possibly even into the realm of the unknown and terrifying? Founded in 1954, CERN has become one of the world's most prestigious and vital research centers, boasting 23 member states and a vast network of experts. While the LHC is its most high-profile project, it is only one part of an expansive array of accelerators and detectors aimed at understanding the universe's smallest components. The LHC is a race to uncover the very building blocks of existence. It accelerates protons to nearly the speed of light, sending them on a collision course that simulates the energy and conditions of the universe at its inception. The temperatures produced are millions of times hotter than the sun's core, while an intricate web of magnets guides these particles along their journey. At the same time, highly sophisticated cooling systems maintain the system's supercold environment, far colder than even outer space. The LHC is equipped with 1,232 dipole magnets that steer the proton beams and 392 quadrupole magnets that focus the beams just before they collide. Another crucial type of magnet helps increase the probability of collisions by pushing particles together with incredible force. Essentially, CERN's mission is to collide particles with such precision that it is akin to hitting two needles placed 6 meters apart. The accuracy required for this operation is staggering, and the technology involved is unparalleled. The collider's construction features concentric rings placed deep underground, shielding them from the harmful effects of radiation. To achieve optimal performance, the entire system is cooled to -46 degrees Fahrenheit, colder than even the vacuum of space. The underground setup houses 4 distinct particle detectors: Atlas, CMS, ALICE, and LHCb, each with a unique purpose in investigating various aspects of particle physics. These detectors are equipped with massive cameras that capture the particle impacts, with experts constantly analyzing the data in search of traces of the elusive Higgs boson. The Higgs boson is thought to be integral to understanding the very fabric of the universe, offering insights into its essential structure. In many ways, studying the microcosm helps us unravel the macrocosm of the universe, much like solving a massive cryptic jigsaw puzzle. However, with each piece we place, new questions and mysteries emerge, reminding us that every discovery leads to another challenge. The LHC is not merely a scientific tool. It is an embodiment of human ambition, progress, and the relentless drive to comprehend the fundamental forces that shape our universe. But as we venture into the unknown, we must also confront the moral and existential dilemmas that accompany such daring exploration. What are the potential risks of delving into the unseen? Could our quest for understanding unleash forces beyond our control? In recent months, an unsettling revelation has sent shockwaves through the scientific community. Brian Cox, a former CERN researcher and prominent voice in the field of particle physics, made a statement that has both intrigued and alarmed his colleagues. According to Cox, the LHC's mission to recreate a miniature version of the Big Bang, reproducing the very event that gave birth to our universe, could lead to unforeseen consequences. The collider's impressive ability to probe the Higgs boson and explore the enigma of dark matter a substance that constitutes a significant portion of the universe, could potentially unlock truths beyond our comprehension. While the idea of uncovering the universe's deepest mysteries is exhilarating, it is also fraught with risk. The LHC recreates the extreme conditions present at the universe's inception, simulating temperatures, pressures, and energies unlike anything we can observe in everyday life. It is as if we are peering directly into the moment the universe began. Yet such immense power brings with it an immense responsibility. Consider the incident involving Russian physicist Anat Borsky in 1978. Borsky was conducting research at the U.S. synchrotron at the Institute for High-Energy Physics when a tragic accident occurred. A proton beam accidentally penetrated his skull, causing significant tissue damage, but he miraculously remained conscious and even walked to seek medical attention. His experience serves as a stark reminder of the potential dangers associated with particle accelerators. The power harnessed by these machines should never be underestimated. Concerns about the LHC's capacity to create black holes, albeit on a very small scale, have raised alarms among some in the academic community. Black holes are regions of space with such intense gravity that not even light can escape. Some scientists have expressed concern that the LHC might create a miniature black hole, one that could theoretically consume the Earth from the inside. While CERN researchers have reassured the public that any black holes generated would evaporate almost instantly and pose no threat to the planet, this theoretical possibility has nonetheless sparked fear and intrigue. The idea of a black hole being created by high-energy particle collisions has been the subject of much debate and has added to the growing awareness of the risks associated with such powerful experiments. Understanding the mechanics of the LHC is crucial for grasping its potential to create a black hole. When protons are accelerated to nearly the speed of light and collide, the energy produced is so vast that it distorts the fabric of spacetime itself. This effect can be likened to jumping on a trampoline, causing the surface to bend and warp. These distortions in spacetime raise the unsettling question: could such shifts lead to the formation of a black hole? In the strange and mind-bending world of quantum physics, where the universe's fundamental laws appear to defy logic, there exists a theory suggesting that unknown aspects of our reality may be hidden within the very fabric of space. If such elements exist, the LHC could potentially tap into them, sparking the creation of a gravitational anomaly capable of forming a black hole. This possibility has garnered attention from some of the most distinguished scientists in the world, including the late Stephen Hawking. In his writings, Hawking warned of the potential dangers of the LHC, especially if the Higgs boson behaves unpredictably at high energy levels. Such an anomaly could trigger a catastrophic event known as vacuum decay, which might not only annihilate the Earth but unravel the very fabric of the universe itself. Renowned cosmologist Sir Martin Rees also acknowledged the potential hazards of particle accelerators in his writings about humanity's future. Rees suggested that experiments at CERN could potentially trigger a vacuum instability, a hypothetical event that could cause catastrophic changes in the structure of spacetime. While the likelihood of such an event remains low, the consequences would be catastrophic if it were to occur. Certain scientists are fully aware of these risks and have implemented extensive safety protocols to minimize any potential dangers. However, the nature of scientific exploration means that some degree of uncertainty is inevitable, particularly when exploring uncharted realms. The pursuit of knowledge has always carried an element of risk, but it is this very willingness to push boundaries that has driven human progress. The LHC symbolizes humanity's unrelenting curiosity about the universe, embodying decades of scientific achievement. Yet, the potential risks involved in such groundbreaking research cannot be ignored. Although the chances of a catastrophic event occurring remain low, the consequences could be world-altering. As we continue to explore the universe's mysteries, it is essential for scientists, policymakers, and the public to engage in open and transparent discussions about the ethical and existential implications of these experiments. In conclusion, the Large Hadron Collider at CERN stands as a monumental testament to human ingenuity and scientific achievement. It provides invaluable insights into the fundamental nature of the universe, but with such immense power comes a significant moral responsibility. As we continue to uncover the secrets of the cosmos, we must ensure that our pursuit of knowledge does not come at the expense of our safety or well-being. The LHC is a powerful tool in our quest for understanding, but it also serves as a stark reminder of the profound ethical considerations that come with exploring the unknown. As humanity pushes the boundaries of scientific discovery, the LHC remains an extraordinary example of our desire to understand the universe. The sheer scale of the project speaks volumes about the ambition behind it. Over 10,000 scientists, engineers, and technicians from all over the world collaborate to ensure the machine's success. The scale of the data collected by the LHC is staggering, with experiments generating petabytes of data every year. The storage and processing power required to handle this immense amount of information demand cutting-edge technology that has revolutionized fields such as computing and data science. The results from the LHC experiments go far beyond particle physics, extending into areas like medicine, material science, and even environmental studies. The study of the Higgs boson, for instance, could have far-reaching implications beyond our comprehension of the universe. The particle, which is integral to the standard model of particle physics, plays a crucial role in giving other particles mass. Without the Higgs field, the universe would be vastly different, with particles floating around in an empty, massless state. However, beyond the basic understanding of the Higgs, scientists are also keen to understand how the particle behaves under extreme conditions. These studies could lead to insights that impact everything from the development of new materials to understanding the fundamental forces that govern the universe. One of the other critical aspects of the LHC is its exploration of dark matter. Dark matter is an invisible substance that accounts for around 27% of the universe's mass energy content. Despite its immense presence, scientists have not yet directly detected dark matter. The LHC's experiments aim to reveal the potential particles that may make up dark matter by observing the behavior of particles created during high-energy collisions. If dark matter is finally identified, it could change the way we perceive the universe, unveiling hidden dimensions of space-time and altering the foundations of modern physics. In addition to dark matter, the LHC is exploring other exotic realms such as supersymmetry and the potential existence of extra dimensions. Supersymmetry is a theory that proposes a relationship between two basic classes of particles, bosons and fermions. This theory predicts the existence of superpartner particles that have yet to be observed. The discovery of supersymmetry could open the door to a new understanding of the fundamental forces of nature, offering a deeper insight into the interactions that govern our world. Furthermore, the LHC plays a crucial role in advancing quantum computing. By understanding the behavior of subatomic particles, researchers can gain valuable insights that could revolutionize the way we process information. Quantum computers, based on the principles of quantum mechanics, have the potential to solve problems that are currently beyond the reach of classical computers. The technologies developed for the LHC's experiments, such as specialized detectors and advanced computing algorithms, have already influenced the field of quantum computing, paving the way for future breakthroughs. Despite its undeniable benefits, the LHC's work also raises fundamental questions about the future of humanity. The search for the unknown can be exhilarating, but it also comes with the responsibility of considering the possible unintended consequences. The very technology that drives the LHC could be used for purposes that could harm humanity, such as in the development of advanced weapons or creating scenarios that are beyond our control. Ethical debates surrounding the LHC are not limited to just the risks of catastrophic events like black holes or vacuum decay, but also include the potential application of the research. How do we ensure that this knowledge is used responsibly and that the pursuit of discovery does not inadvertently lead to harm? As we explore the unknown, it is crucial to engage in ongoing conversations about the balance between scientific progress and ethical responsibility. The global nature of the LHC's work requires the cooperation of multiple countries, each with their own values, priorities, and concerns. Transparency in research, accountability, and collaboration between nations will be essential in ensuring that the knowledge gained through these experiments benefits humanity as a whole rather than causing unforeseen damage. The work of CERN through the LHC serves as a reminder that scientific achievement must always be tempered with careful consideration of its broader consequences. Another issue of concern is the potential for unforeseen ecological impacts of particle accelerators. While the LHC is a relatively contained environment with no immediate environmental consequences, the enormous energy requirements of such machines are worth noting. The environmental footprint of particle accelerators, especially those requiring massive amounts of electricity and producing heat, could strain natural resources and ecosystems. The energy demands of the LHC are immense, and although efforts are being made to use renewable energy sources and improve efficiency, the broader question of sustainable scientific exploration must be addressed. Ultimately, the path forward will require a delicate balance. The LHC represents humanity's drive for knowledge, exploration, and discovery. However, with every scientific breakthrough comes the need for ethical reflection and responsibility. The risks involved in such experiments cannot be ignored, but the potential rewards could reshape our understanding of the universe in ways we can only begin to imagine. As we continue this journey into the unknown, the focus must be on ensuring that the pursuit of scientific progress is conducted in a way that is safe, responsible, and beneficial for future generations. In conclusion, the Large Hadron Collider is much more than just a tool for scientific discovery. It is a symbol of humanity's quest for knowledge and its boundless curiosity about the nature of existence. The questions raised by the LHC's work are profound and carry with them significant ethical and existential considerations. However, the LHC also demonstrates that through collaboration and careful oversight, humanity can unlock secrets that have the potential to change the course of history. As we stand on the precipice of these new discoveries, we must remain vigilant, mindful of the potential risks, and committed to the ethical use of the knowledge we uncover. In the end, the quest for understanding must always be guided by the responsibility to safeguard our future.